Alright, big dog, back with another problem. So we're going to be sketching these graphs, third degree polynomial. That means x third would be third degree. So basically, all we're going to do here has to have two complex and one real. All you do for the real is it has to touch the x-axis. And then for the complex, it can't touch the x-axis. And how I know it's third degree is if I drew a line here, how many times would my equation go through that line? So go through here once, twice, and 3 times. So that's how I know it's third degree. But since my x-axis is down here, it's going to have one real root and two complex. Next one. Gotta solve these Johns real quick. This is going to be at 4. This is going to be at 1, -3. So I'll just kind of roughly estimate these real quick. I don't really like drawing my graphs too highly. So we have to figure out the degree first. So it's going to be 2 plus 1 plus 1, which is 4. 4 is even equation, whatever they call those things, I don't know. So that means if it starts negative, it has to end negative, or if it starts positive, it has to end positive. And I can tell this one's going to start positive, because if it started negative, it would have a negative out front in front of the whole thing. So all we're going to do here is draw, boom, boom, boom. And now I'll explain it. So if it's a first degree, it just goes through the point. So it did at x equals -3 and x equals 1. And if it has a second degree, it's gonna kind of bounce, I think is what they call it. So it just hits the point and then it goes back in the same direction. Alright, next one. We got at 1, -2, and 5. And then our degree is 1, 2, plus 3 is 5. This one's gonna go boom, 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 boom. Maybe. I don't know. It's gonna start positive and go negative. So we'll go put these points down roughly. Start positive. It's gonna go through the first, through the second, and then if you've ever seen a third degree polynomial, they like shimmy, kind of, I don't know what they call it. They do a little like weird thing when they go through it. So we're gonna draw that little weird thing through it. Know what I'm saying? So that's, I can't draw this very well, but pretend this is a third degree going through that point. That's all it's doing right there. Oh, pretty easy. Draw graphs. If they ask you for the y-intercept, all you gotta do is plug in the points to your calculator. Or you can just plug in a number. You plug in 0 for x, multiply out all the roots, and then you'll get what y equals. So let's say we'll do a really easy one. Y equals x times x minus 1 squared. Now we plug in 0. Here we'll do x plus 3. Plug in 0. So you get 3 times negative 1 squared. That's going to be 3. So our y-intercept would be 3 for this equation. Pretty easy way you can determine that. Otherwise, just look at your calculator, just cheat. I mean, it's not really cheating, but, Alright, next problem. Square both sides. X squared plus 4 equals 4. Subtract 4x squared equals 0. X equals 0. Now plug it back in. 0 plus 4. Take the square root of 4. 2. So we got 2 equals 2. True. X does equal 0. Next one. Square both sides. 2x plus 13 equals x squared plus 10x plus 25. Now I shift it to one side. Now we're going to factor that Johnson. So we got x equals 6 and x equals 2. Alright, now we have to plug it back in. See which one is the right one. So we got 2x plus 13. We'll plug a 2 in first. 2 times 2 is 4 plus 13, 17. Square root of 17 is not equal to 2 plus 5. So it's not that one, probably. Next one. Six times 2 is 12 plus 13 is 25. Square root of that is 5. 6 plus 5 is 11. So, I don't know. I got the right answers for the roots. They're just not equal. For some reason, it's kind of weird. But I'm going to say x minus 2 is definitely not the right one, and this one is probably the right one. So I am. Let's check. Yeah, I got the right roots. I don't know.